Hello everyone. So our today's topic is properties of alkane. As we have seen the preparation of alkane, our today's topic is properties of alkane. So first we will see chemical properties, then physical properties. The chemical properties of alkane. Generally, alkenes are generally inert towards acid bases and oxidizing and reducing agent. However, they undergo few reactions under certain conditions. Let me write this. Alkenes are generally inert towards acids, bases, oxidizing and reducing agents. Now let's see chemical properties of alkene. First, we'll see combustion. Alkenes on heating in the presence of air or dioxygen are completely oxidized to carbon dioxide and water. This reaction is called combustion. Alkenes on heating in presence of air or dioxygen are completely oxidized to carbon dioxide and water. CO2 and water. And large amount of heat is evolved. This is the methane reacts with dioxygen completely oxidized to carbon dioxide and water with the evolution of large amount of heat. This is enthalpy of combustion, that is minus 890 kilojoule mole inverse. The general equation for any alkane for combustion is O2 and CO2 plus N plus 1 H2O. Due to the large amount of heat during combustion, alkenes are generally used as fuel. If if incomplete combustion of alkene is happening with insufficient amount of air or dioxygen, carbon black is formed, which is used in manufacture of ink, Means with insufficient amount of air or dioxygen, carbon black is formed, which is used in manufacture of ink, printer ink, black pigments, and as filters. Now, next reaction is halogenation. One or more atom of Our next reaction is halogenation, in which one or more hydrogen atom of alkane can be replaced by halogen. Hydrogen atom can be replaced by halogen. Let's see. Now, our next reaction is halogenation. One or more hydrogen atom of alkane can be replaced by halogen. Hydrogen atom of alkane can be replaced by halogen. This reaction is called halogenation. Let's see. This is your alkane halogen in the presence of sunlight. Now, what will happen next? Let me explain the reaction to you. In the presence of sunlight, checks. For example, methane plus chlorine in the presence of sunlight. What will form? Hydrogen is replaced by halogen. That is, hydrogen is replaced by chlorine. H2, Cl2. This is dichloromethane. Dichloromethane. Dichloromethane is formed. Now, in the next step, dichloromethane with chlorine in the presence of sunlight. Trichloromethane is formed. Trichloromethane. Now, trichloromethane, chlorine in the presence of sunlight. Tetrachloromethane is formed. Tetrachloromethane. Now, this is the final product as we have no left hydrogen to replace. So, this is the reaction, halogenation. Now, let's see the mechanism of halogenation. The very first step is chain initiation. that is formation of radical. First step is chain initiation. Chain initiation is step of initiation of homolysis of halogen molecule. Initiation initiation of so chain initiation is the step of initiation of homolysis of chlorine molecule in the presence of light or heat. This is a chlorine molecule in the presence of light or heat. Homolysis. Formation of free radical. Chlorine free radical is formed. Next step is chain propagation. The chlorine free radical attacks methane molecule and takes the reaction in the forward direction by breaking carbon hydrogen bond to generate methyl radical with the formation of HCl. The chlorine free radical attacks methane to take the reaction forward and generate methyl free radical with the formation of HCl. Now the chlorine and methyl free radical generated above in this step, they they react like now the chlorine and methyl free radical generated above in this step, they they react like the next step of chain propagation is methyl free radical react with chlorine molecule in the presence of sunlight only. Methyl chloride plus chlorine free radical is formed. Now the next step is chain termination step. chain termination. The reaction stops after some time due to consumption of reactants or radicals. Possible chain termination steps are methyl free radical and chlorine free radical are also present in the reaction. Now, let's talk about some important points of the reaction. This is a free radical substitution reaction. Now, let's talk about the rate of reaction. The rate of reaction of alkanes with halogen is fluorination is too violent to be controlled, and iodination is very slow and a reversible reaction. It can be carried out only in the presence of oxidizing agents only. Let's see. Fluorine is extremely violent, uncontrollable reaction, and iodination is slow and reversible reaction. Iodination is only carried out in the presence of oxidizing agent like HiO3 or HNO3. Let's talk about iodination. Iodination of alkane. Iodination is slow and reversible reaction. So, this is iodination of alkane. Now, next reaction is now next reaction is nitration. Nitration is carried out in vapor phase nitration at high temperature. The reaction is feasible. Our next reaction is nitration. It is vapor phase nitration and is carried out at high temperature. CH3CH2 concentrated HNO3 CH3CH3 is there, not CH3CH2. CH3 CH2 NO2 plus H2O. Now the nitration is carried out by two ways. One is CH bond is breaking, CH bond breaking, and second is CC bond breaking. Carbon-carbon bond is breaking, carbon-carbon bond breaking. If carbon-hydrogen bond is breaking, only it is addition of NO2 only. And if carbon-carbon bond is breaking, you have to break carbon-carbon bond by NO2, NO2. See, this is carbon, carbon hydrogen bond breaking, carbon hydrogen bond is breaking. That means we have to add NO2 only. Replace your hydrogen with NO2. This is what happening here. See, this is molecule concentrated HNO3. If carbon carbon bond is breaking, यहाँ भी NO2 आएगा and यहाँ भी NO2 आएगा. That is CH3, two molecules of CH3, CH2, NO2. The next section is sulfonation. carried out in the presence of concentrated H2SO4 or forming H2SO4 or oleum. Alkane concentrated H2SO4 replaced by RSO3H. You can understand this reaction as H2SO3H, that is H2SO4 water is released RSO3H. The important points of this reaction is rate of reaction is directly proportional to the stability of free radical. Some important points or highlights of the reaction are rate of reaction is directly proportional to the stability of free radical. Second is reaction is feasible when alkene having 6 or more than 6 carbons. In case of lower alkenes, it is only feasible when 3-degree hydrogen is present. Alkenes, alkenes with 6 or more than 6 carbon atom in the presence of oxides of chromium or vanadium or molybdenum oxide, vanadium oxide, molybdenum oxide. 6 carbon atom, 6 carbon atoms are present here. Alkane product is formed, that is benzene. If 1, 2, 3, 4, 5, 6, 7. 7 carbon atoms. 1, 2, 3, 4, 5, 6. Only branching is increased. It is toluene. Next reaction is reaction with steam. Reaction with steam. Methane reacts with steam at 1273 Kelvin in the presence of nickel catalyst to form carbon monoxide and dihydrogen. This method is used for industrial preparation of dihydrogen gas. Methane reacts with steam in presence of nickel catalyst at 1273 Kelvin to form carbon monoxide and water and dihydrogen. Sorry, carbon monoxide and dihydrogen. This method is used for industrial preparation of alkane. क्या करें पागल हूँ। The next reaction is reaction with steam. Reaction with steam. Reaction with steam. Methane reacts with steam at 1273 Kelvin in the presence of nickel catalyst to form carbon monoxide and dihydrogen. This is the industrial preparation of dihydrogen gas also. When methane reacts with steam in the presence of nickel, nickel catalyst at 1273 Kelvin to form carbon monoxide and dihydrogen, which is also called as water or syngas. Water gas or syngas. This is the method to prepare dihydrogen industrially also. The next section is pyrolysis. Pyrolysis higher alkane on heating to higher temperature decompose into lower alkanes. This reaction is called as pyrolysis. Such a decomposition of higher alkanes into fragments by the application of heat is called as pyrolysis or cracking. This is also called as cracking. Higher alkane. What is happening? Higher alkane God C6H14 at higher temperature decompose into lower alkane. HF plus C2 H6 H6 plus C2H4 plus CH4. This reaction is believed to be a free radical reaction. Preparation of oil gas or petrol gas from kerosene, oil, or petrol involves the principle of pyrolysis. Okay. Next reaction is controlled oxidation. Controlled oxidation. Controlled oxidation is alkanes on heating with a regulated supply of dioxygen or air at high pressure in the presence of suitable catalyst give a variety of oxidative or oxidation products. Alkanes, alkanes on heating with dioxygen with suitable catalyst and give a variety of oxidation products. Methanol is formed. methanol, CH4, methane plus O2. Let's change the catalyst and the product is changed. Product formed is methanol. It's three alkenes only, CH3 plus O2 dioxygen. The product formed is methanoic acid. Methanoic acid. Now, ordinarily, alkane resist oxidation, but alkanes having tertiary hydrogen atoms can be oxidized to corresponding alcohol by potassium permanganate. Alkene having tertiary hydrogen. Alkene having tertiary hydrogen is the most important thing or point. Alkene having tertiary hydrogen can be oxidized to corresponding alcohol by potassium permanganate. Can be oxidized to corresponding alcohol by potassium permanganate. This is your to give corresponding alcohol in the presence of potassium permanganate. Now let's see the physical properties of alkane. Now let's start with physical properties of alkane. The very first property of alkane is alkanes are generally nonpolar. Alkanes are generally almost nonpolar compounds. Nonpolar because of because of the covalent nature of carbon carbon and carbon hydrogen bond and bond due to little electronegativity difference, due to very little difference of electronegativity. Difference of electronegativity. Second is they possess weak van der Waals forces. Alkene possess weak van der Waals forces. Alkene possess weak van der Waals forces. Now the next property is next property is from carbon 1 to carbon 4, alkanes are gases from carbon 5 to carbon 17. Alkanes are liquid. Carbon 17 to beyond. Alkanes are solids. Carbon 17 to beyond. Alkanes are solids. Solids. Now, now the next property is now the next property is their alkenes are colorless and odorless. Colorless, odorless, odorless. Next is hydrophobic. They are in nature. Alkenes are hydrophobic in nature. Alkanes are hydrophobic in nature. If the boiling point is directly proportional to the molecular weight, if the molecular weight increase, boiling point also increase because the number of carbon atom increase. If the molecular weight increase, boiling point also increase because the number of carbon atom increase. Carbon atoms increase. Now, the next property is if branching increase, then the boiling point decrease. Branching increase, that means the branching increase, then boiling point decrease. If branching is increasing, that means the boiling point is decreasing. See, here branching is increasing one by one, so the boiling point is decreasing. The first one has the highest boiling point, second one highest than the third one, and third one is has the lowest boiling point. So today we have completed the topic properties and preparation of alkane. Now in the next video we will see preparation of alkene and properties of alkene. So see you in the next video and please subscribe the channel and wait for the next video. Thank you. Thank you so much for watching.